Hydrocarbons, as the name suggests, are compounds containing only carbon and hydrogen. Whereas organic compounds may contain other elements like oxygen in case of alcohol, aldehyde, ketone, halides, nitrogen in case of amines, amides, nitro group, sulfur, okay, so etc. And even metals. So organic compounds are hydrocarbon derivatives. Okay. So organic compounds are derived from hydrocarbons. They are obtained from hydrocarbons. Not always, but many a times. So we have studied about organic compound, which is a broader science. Now we have to confine ourselves and we have to study organic hydrocarbons. If I would have been the author of the book, I would have kept hydrocarbons as the first chapter and organic chemistry later on. But why in your NCRT book hydrocarbon is kept after organic chemistry is that the base of this is in class 10. In class 10, you have studied this under the chapter carbon compounds. Carbon and its compounds. So you will find that many topics will be common from class 10th and there will be little more advanced things which are related to class 11th. Okay. So organic chemistry part we have done. Now we are going to start hydrocarbon. Whatever I am teaching is in recording mode, so you can always visit it later on also. So what happened around 300 million years ago? There was a big earthquake. So when it was a big earthquake, then it so happened that under the ocean, there were bedrocks. It was ocean, say, and inside the ocean there were bedrocks. Deep under the ocean, if you go, then you can find mountains are also there, hills are also there. Okay, so there is some kind of earth crust inside the ocean also. Okay, so this is called as bedrock. And this was the ocean. And above ocean, there was terrestrial field. Terrestrial field means the place where we live. So this is terrestrial area. Now in the ocean also, there are floras and faunas. There are planktons, flora, fauna. Okay, there are flora and fauna. And in the terrestrial area also, there are flora and fauna. Flora means animals, flora means plants, and fauna means animals. Okay. So all together we call them flora and fauna. Okay. Now when the earthquake took place, then all this flora and fauna went deep inside the earth crust. Okay. All this flora and fauna went deep inside the earth crust. So what happened? Due to earthquake, burying of organisms where I mean that they are flora and fauna. Okay, flora and fauna, they got buried under the earth crust. Now when they were buried under the earth crust, then what happened? In 300 million years time, fossilization of the carbohydrate took place. Fossilization means formation of fossil took place. Okay, so all the carbohydrates which was there in their body, protein, they all underwent fossilization due to lots of heat. Under the earth crust, what is there? Lots of heat is there. Lots of pressure is there. Lots of heat is there. Lots of pressure is there. Now, due to this lots of heat and lots of pressure, this flora and fauna, they became rock oil. They converted themselves into rock oil. This rock oil is now called as petroleum, which we together say as petroleum. Petroleum. Oleum means oil. Petra means rock. Okay. Petra means rock and oleum means oil. So in this way, petroleum was formed under the bedrock of the ocean. Which nowadays we put lots of cylinders inside like this, and with the help of pump we take out this petroleum. So in Bombay High you will see that if you have gone to the Bombay beach, or if you have gone to Digboi in Assam, you will find that petroleum is taken out. Petroleum is taken out from here. Petroleum is extracted using these pipes. Okay, so you can find all this happening in places like Bombay High, now who conducts all this activity in our country? In our country, these are conducted by ONGC, Oil and Natural Gas Company. Okay. So in our country also lots of petroleum is found, not only in Gulf countries, but also in our country, we are able to get petroleum. Now, what happened under the earth crust in the terrestrial area? In the terrestrial area, there was lack of water. It was dry area. As a result, coal was formed. Coal. In the dry area, coal was formed. Whereas in the wet area where water was there, oil was formed. Okay. So in this way, the carbohydrates converted themselves into hydrocarbons. Carbohydrates became hydrocarbons. And this process is called as fossilization. Now, let us try to understand what is carbohydrate. Let us see simplest carbohydrate. Glucose. What is the formula of glucose? C6H12O6. Sucrose. What is the formula? C12H22O11. What is common here? What do you find common here? You will find that it is like C6 and H2O is also 6 times. 6 twos are 12 and 6 ones are 6. Now, since it is a disaccharide, it is made up of 2 glucose. Okay. So here also it is in the form of C12H2O 12 times and one H2O comes out, minus one H2O. So they are hydrated hydrocarbon. So see, are they not hydrated? They contain lots of water. Okay, so they are hydrated hydrocarbon. And that is why they are also named as carbohydrate. But it is not hydrocarbon, it is hydrocarbon derivative. Okay, these are all hydrocarbon derivatives. Derivatives means the one which we obtain from the other. These are hydrocarbon derivatives. How many are present? 12 students are present. Okay. Someone take the attendance also. Now we'll come to the only hydrocarbon part. I have done enough in an introduction. So hydrocarbons mainly are of 2 types. Due to the property of catenation of carbon, they form a long chain, and the chain can be a straight chain. It could be a straight or open chain. Hydrocarbon, or it could be a cyclic or closed ring hydrocarbon. Due to tetravalency of carbon, each carbon can form bond with 4 hydrogen atoms. But if number of hydrogen atoms are lesser than 4 or 3, and in a long chain of hydrocarbon, carbon is attached with another carbon using any double bond, then we call them as unsaturated hydrocarbon, because in such kind of hydrocarbon more hydrogen can be added. So both of these can be saturated or unsaturated. Saturated ones are called as alkanes, like CH4, C2H6, and so on. Unsaturated one are like double bond containing carbon compound and triple bond containing carbon compound. So double bond containing is called as alkene, and triple bond containing hydrocarbon is called as alkyne. So it is CH2 double bond CH2 and the homologous series, that means the longer chain of that, and C triple bond CH. Okay. You will find that the general formula of alkanes in cyclic compound, let us say cyclic compounds, the first member of cyclic compound could be only a cyclopropane, because to close a ring 3 points are required. Cyclopropane, cyclopropene. Alkynes are rare in cyclic compounds. Cyclic alkynes are rare because cyclic alkynes are rare. Cyclic alkynes are rare because multiple covalent bond causes ring strain. Let us study this in more detail. So if I take cyclopropane, so it will be equilateral triangle. Now if I make cyclopropene, it will not be an equilateral triangle. This bond will be shorter bond. Because it is doubly bonded. Double bonds are shorter bonds than the single bonds. So this bond will be short. So it will be a kind of isosceles triangle. But if I make triple bond, then there will be ring strain, because this bond will be very short. As a result, this carbon will not be able to come close to this carbon and it will break up. It will break due to ring strain. But if the ring is made up of a longer carbon, say for example, if I take cyclohexane, cyclohexene, and cyclohexine, it is possible, but it is unstable. It is possible, but unstable. It is relatively stable and it is most stable. This is named as cyclohexane. This is cyclohexene. hexene, and this is cyclohexyne. What are homologous series? Hydrocarbons which has different number of carbon and hydrogen, but same general formula, are homologous series. Example, if I take CH4, so number of carbon I have taken is 1, number of hydrogen I have taken is 1 into 2 plus 2. If I take C2H4, C2H6, then number of carbon is 2, number of hydrogen is 2 into 2 plus 2. If I take C3H8, it is C3H 2 into 3 plus 2. If I take C4H10, I am taking C4H2N, that means 2 into 4 plus 2. So what do we see here? If carbon atom number is n, the number of hydrogen will be 2n plus 2. So this is general formula. So general formula is same for all, for this, for this, for this, for this, but number of carbon and hydrogen is different in each of these. And hence they are called as homologous series. Series means arrangement in a particular pattern. So they are homologous. They have same general formula, but different number of carbon and hydrogen. Similarly, we can have homologous series of alkenes. So these are of alkanes. In case of alkenes, what happens? For alkene to form, at least 2 carbon atoms are required. So say if it is alkane, first of all, let me make one alkane. This is ethane. And ethene is carbon-carbon double bond, 1H, 1H, 1H and 1H. It is unsaturated. It is ethene. It is unsaturated because it can add more hydrogen. Because it can add more hydrogen. If you give hydrogen gas adsorbed in nickel, then it will undergo hydrogenation. So more hydrogen can be added. So you will find that as many number of hydrogen atoms will be there here, 2 will be less here. So if it is general formula, if general formula of this ethane is CnH2n plus 2, then it will become what? CnH2n plus 2 minus 2. This will be cancelled. So its general formula will be CnH2n. Next, if it is an alkene, And if it is an alkyne, whenever there will be double bond, then it should be 120 degree, and it should be sp2 hybridized. And whenever there will be triple bond, it will be 180 degree, and it will be sp hybridized. Each of the carbon will be sp hybridized. Very clearly you can see that it is forming a trigonal planar structure, and here it is forming linear structure. So as many number of hydrogen atoms are here, two are lesser for this. General formula for this was CnH2n. General formula for this will be CnH2n minus 2. So on and so forth. Keep on increasing number of carbon atoms, you will get all the homologous series of alkynes like ethyne, propyne, butane, and so on. So this can also be hydrogenated using hydrogen in nickel. It is not wrong to say that it is an addition reaction. It is a type of addition reaction. Why? General formula of alkane of say alkene and cycloalkane, alkene and cycloalkane are same. See here, if I write carbon, 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 double bond, hydrogen, hydrogen, one hydrogen, one hydrogen, one hydrogen, one more hydrogen. So this is just like beads of any garland. These are just like the beads of any garland. One bead, another bead, third bead. Why can't I just make them a triangle? I can always make them a triangle. So this can become one carbon, two carbon, and three carbon. But for the bond to be formed, what is required? For the bond to be formed, unpaired electrons are required. So here this pi electron, one electron can go to this carbon, and one electron can go to this carbon, and there can be there can be a rearrangement reaction such that this unpaired electron will go to this carbon, and then it will form like this. One carbon, two carbon, three carbon. Here the double bond was there. It was CH3 earlier. It was CH2 earlier. So what can happen is this bond can rotate and can form bond here. Now when it will form bond like this, then what will happen? This will start breaking, because one carbon cannot have five bonds. 1, 2, 3, 4, and 5. 5 bonds cannot be there. So when it will form, this will break. Now after breaking, what will happen? After breaking, this will go and join here. So what will form? It will form like this: carbon, 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 and each of the carbon will have two hydrogens. One hydrogen, another hydrogen, one hydrogen, another hydrogen, one hydrogen, another hydrogen. So we have seen today classification of hydrocarbon, how hydrocarbons are formed, and what is the structure of hydrocarbon, like hybridization and everything. I'll just show you the three-dimensional structure once, and then we will leave for today for studying preparation tomorrow. So how can we show three-dimensional structure? Although I had shown you in the previous chapter, but I'll show it once again. And that will be the last topic of today. So this is carbon. One hydrogen will be here, another will be in the same plane. Third comes out of the screen of your device. And one goes inside your device. So an alkane is always has sp3 hybrid carbon. And its bond angle is, either you can write 109 degree, 28 minutes, or you can write 109.5 degree. But if it is alkene, then it will be sp2 hybridized. It is sp2 hybridized, and the bond angle is always 120 degree, and it forms a triangular planar structure. A triangular planar structure. In case of alkynes, carbon atoms are sp hybridized, and their bond angle is 180 degree only. So that's all for today. We will be studying about preparation and properties of hydrocarbons. All right, from our next class. Thank you. Please send me the attendance.